Okay, welcome back for the second installment of the video series for ChemQuest 27. All right, we're going to look at student response questions 3 through 8, the critical thinking section. This is dealing with formulas and percent composition. So we're going to synthesize two concepts here. Again, make sure you have your calculator, your periodic table in front of you so that you can follow along and not just get good at watching Mr. Huderberg do chemistry. All right, so question number 3. Again, we're going to have our little reference table down here that shows us how to calculate percent composition. You guys should be pretty good at that by now. All right, what we're going to do, though, is we're going to take a look at what's called structural formula and a molecular formula and relate that to percent composition. And we're going to see what sort of inferences smart people can make. All right. That means you, by the way. You're one of those smart people. All right. Anyways, so what it says here is to verify that percent. So verify means check to make sure that this looks correct to us. Okay, that the percent composition of carbon and hydrogen given for hexene in table 1 are correct. So hexene is that one at the very top. So it gives us the name, gives us the structural formula. All right, and then a molecular formula, C6H12. And so for percent composition, we're probably just fine looking closely at this. All right, so it gives us the value 14.4% hydrogen, which, by the way, we can immediately infer because there's only two elements in that compound, carbon and hydrogen. Since the hydrogen is 14.4%, we can immediately infer that this is 85.6% carbon because, right, if we know carbon or hydrogen is 14.4%, if I go 100% minus 14.4, I get 85.6, right? And that's where that comes from. So we don't actually have to go through the trouble of taking the mass of 6 carbons and dividing it by the total mass, right? Once we know the mass or the percent composition of one of the two, we can quickly do that. Now, if there's more than one element present, all right, we can't just do that simple calculation. Okay, but so let's verify though. It does say to check to make sure that those are in fact correct numbers. So let's go through the process. We were given the percent composition of hydrogen as 14.4%. So let's see whether we actually get that same number. All right, so the mass percent composition of element X being hydrogen in this case. So I'm going to set up my fraction. I'm going to go 12 hydrogens, so 12 times 1.01 over the combined mass, which would be 6 times 12.01, which would be those 6 carbons plus the 12 hydrogens. All right, and when I simplify that expression down, I should get 72, no, excuse me. I should get 12.12 over a combined mass of 84.18. And then we'll multiply that by 100, and I should get something pretty darn close to 14.4% hydrogen. Verified. Check. All right. Next one, fill in all these blanks. What? Okay. So we're going to do a couple things. This one's going to take us a little longer to work our way through as we demonstrate what's happening here. But let's take a close look. So we have 14.4% hydrogen. We already said that this is 85.6% carbon there. All right. Now, here for propene, we get this structural formula right here. It doesn't give us a molecular formula, but we can just do some simple counting. So we got 1, 2, 3 carbons. So C3, and then 1, 2 hydrogens there. One more makes 3, plus 3, 6. So C3H6. All right. Now, this might not jump right out at you, but this is going to be important later on, so I'm just going to bring it up early. We have 6 and 12, which is a 1 to 2 ratio, right? There's half as many carbons as hydrogens. that same ratio pops up right here. 3 carbons, 6 hydrogens. For every 1 carbon, there are 2 hydrogens. So we have the same ratio for propane and hexene. C6H12, C3H6, same ratio. So in theory, we ought to get the same percent composition. But let's just do a quick verification here. So if I take, let's go percent composition of hydrogen. So I'm going to go 6 hydrogens. So 6 times 1.01 over combined mass of 3 carbons. So 3 times 12.01 plus those 6 hydrogens. Simplify that expression down and divide. All right, I should get 6.06 over 42.09, which lo and behold, if I multiply by 100, let me fix that, that's horrible. Be patient with me here, sorry. All right, let's go back. So 6.06 times divided by 42.09 times 100. I should get a whopping 14.4% again. So I'm going to get 14.4 and 85.6. So interesting inference. Same ratio of the same 2 elements yields the same percent composition. That's going to be a time saver later on. Just a quick hint. All right. So next one we have benzene, and it tells us the molecular formula as C6H6. So here we have a 1-to-1 ratio. So we're not going to end up with the same percent composition. But let's check the rest of our molecular formulas. Cyclobutadiene. Looks like 1, 2, 3, 4 carbons. C4. 1, 2, 3, 4 hydrogens. H4. Hey, C6H6, C4H4, same ratio, right? So we can make that quick inference that if this is 7.8% hydrogen, this is also going to be 7.8%. All right. Now, if we know this is 7.8, we know that this is 92.2 because we just subtract that from 100 to get 92.2, which means this is also going to be 92.2. Remember I talked about time savers? Here you go. All right. Now, then we have 1, 5 hexadiene. This is organic naming, by the way. So let's look at our molecular formula. I have 1, 2, 3, 4, 5, 6 carbons. C6. All right. Then I have 1, 2, 3, 4, 5, 6 hydrogens, C6H6. So not only do we have a 1-to-1 ratio, I have the exact same molecular formula as benzene. That's interesting, right? Which means we can automatically just go 7.8 here and 92.2 there, right? So again, we need some inferences that if it's the same ratio of carbon to hydrogen, we're going to have the same percent composition. So what we just did, we just saved ourselves a bunch of time, right? We know how to calculate percent composition. That's great. If you don't want to use the ratio method and you want to do this calculation every time, you can. Why not? Why not save yourself some time? All right. Moving on. Number 5. Can you determine a compound's structural formula if you are given the molecular formula? And quick answer to that is, if I know this, C6H6, for example, can I tell automatically that that is going to be the structural formula? The answer is no, right? Because we have a C6H6 there with a very different structural formula, right? No, and the reason for that is because one molecular formula can have more than one structural formula, right? So we need a molecular formula, right? Or actually the name is a better indicator of what that structural formula is. You do not need to learn organic naming today or in time in this chemistry class. Someday you might take organic chemistry and learn all that. But the answer is no, you cannot tell the structural formula because a molecular formula has the potential for more than one structure. All right, moving on. Number 6, it says, what is true about the percent composition of two different compounds that share the same ratio? That means, right, that's what we just talked about. Those shortcuts, time savers we talked about. Same ratio equals same percent composition. All right, so all three of the examples here with a 1-to-1 ratio of carbon to hydrogen all had essentially the same percent composition. So 7.76, when I did that math earlier, I just used an extra sig fig. That went round to 7.8 and then 2.2 and so on. All right, so same ratio means same percent composition. Now that's going to be important to us when we get to what are called empirical formulas here. All right. So, number 7, it asks whether we can determine a molecular formula solely from the percent composition. And answer to that again, so if I know this, right, can I automatically tell that? And the answer again is no, right? Can only tell the ratio, right? So again, from 14.4% hydrogen and 85.6% carbon, I know that for every 1 carbon there are 2 hydrogens. So I can come up with several possible molecular formulas. Actually, lots of possible molecular formulas. It could be CH2, for example, or C2H4, or C3H6, or C4H8, right? If I have that information right there, right, what I can't tell is which of those it is. I need additional information for that. All right, so let's do some practice. We have a 1-to-1 ratio here for this first one, CH8, right? So we could go through all the trouble of calculating the percent composition for carbon and hydrogen and writing those in here. But we already have information. If it's a 1-to-1 ratio, like C6H6 or C4H4, we automatically know that it's going to be about 7.8% hydrogen and 92.2% carbon, right? And if you went through and did the math, that's what you'd get. So let's save some time. If we already have percent composition for a 1-to-1 ratio, we already know the percent composition for any compound with a 1-to-1 ratio of carbon and hydrogen. Now for C10H20, that's a 1-to-2 ratio, so we would use this percent composition here, right? Like C6H12 or C3H6, it's going to be 14.4 and 85.6. Boom!